All right, today we are working with rotations and symmetry. The rotations we'll be working with are either 90 degrees clockwise or counterclockwise, and then we'll be doing 180-degree rotations as well. All right, now that we have all of our vocab written down, let's practice. First off, they're going to ask us in example 1 to identify rotations.
Not all of us got it all.
I can bring it back up later. So, tell whether the transformation is a rotation about the origin. If so, give the angle and direction of the rotation. So what does that mean? Pretend you're playing a game of Monopoly or Life or whatever it is. You know how you always have the spinner? And that little pin is in the spinner, that little butterfly clip or whatever? Well, that's your origin. That's the middle. So if I were to spin this, and this one's my original, and then here, down here is my rotation. Get a smaller pen. Okay? So if I were to take this on a spinner, doesn't matter clockwise or counterclockwise, if I were to take my original and I spin it, is this what it would look like on the spinner if we rotated it on the origin? Yes or no?
Yes.
No.
Yes.
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 Yes, it would. And then if and this is 90 degrees from here to here, it would be 90 degrees which way?
Right. Clockwise.
Right, but what do we call it?
Clockwise.
Clockwise. Then if I went 180, then it's going to look like, it would look like this if we were to rotate it. Okay? That would be 180 degrees. And then if we did 90 degrees counterclockwise, it's going to look like this one, but pointing this direction. And we'll pretend they're all the same size. Okay, because they have to be congruent, they have to all be the same size. So yes, it is a rotation of the origin. Now just looking at, they want to know then, if so, give the angle and direction of the rotation. Here was our original, we went down here. What was the angle? What angle was it? We wrote it. It's 90 degrees. And which direction? Don't say right.
Clockwise.
Clockwise. So that one, yes, and it's 90 degrees clockwise. How about B?
Yes.
Here's my spinner. Would that work?
Yes.
Yes.
Yes. Which direction?
Clockwise.
Clockwise.
Counter.
This way? Oh, whoops. I went from the, I did that backwards because my original's on the bottom. Did I go this way or did I go this way? Do we know?
They both work.
No,
Does it tell us?
Doesn't matter.
Oh, yeah, you guys are on it for Friday. Both work. Both work. Which direction when they're right across from each other like that? What degree? What angle?
180.
180. And it works because it's both ways. 180, both ways. Always, whenever it's 180, unless they tell you, it doesn't matter, it's still going to go. One rule for it. How about C?
No.
No, because if we turned it, this would be pointing what, like that?
Yeah.
And so here it would have to be like that. And then here would be like that. All right, so C is no. Now let's learn how to do these. Actually, I'm going to just circle a couple things on this example and then we're going to practice. Here they show us a 90 degrees clockwise rotation. So they went from here to here, 90 degrees clockwise. Now it's not easy to just go count from the axis, the y-axis like we did with our reflections. You can't just go down one here, so I got to go down one there. In rotations, and then over here we did a 90-degree rotation counterclockwise. When we do that, you have to have the ordered pairs. And anytime you see rotate 90 degrees, automatically take your ordered pairs and flip the X and the Y around. Flip every number around, and then we're going to have to change one. And what does that mean? I'm going to show you right here. First, on this example, draw your original on the graph. Draw your original triangle on the graph. Okay, when you have it, there's your original. It should look like that. What quadrant is it in?
1.
Quadrant 1. This is in quadrant 1. Okay, everyone had enough time to get that on?
Yeah.
All right, now they want us, let's see what they want us to do to the original. They say, then find the coordinates of the vertices of the image after a 90-degree clockwise rotation. Sweet. I automatically see 90 degrees. I know I take my originals, which are written, written right here. Here's my originals. I automatically take these and flip them around. So 1 and 1, oh, that's easy. I just make them 1 and 1. 3 and 4, I flip them and get what?
4, 3.
Perfect. I flip them and get 4, 3. And then 4, 0 goes to 0, 4. Now, I'm not done yet. That's the first thing you do when they say 90 degrees. Okay, after I flip them, now I have to decide, do I need to change the signs of the X's, all of this row, or the Y's, all of this row? And by changing the signs, I mean doing what? Multiplying by?
-1.
Multiplying by that -1. Now here's an easy way to help you remember which one you're supposed to change. If I'm up here, there's my arrow. Which way is, they want us to go clockwise. If this is my clock, which way is clockwise? To the left or to the right?
Right.
Clockwise is to the right. So that means, which one is it pointing at? The Y is the one on the right. So these are the ones we have to change all of the signs, multiplying it by a -1. So this goes to a -1, -3, -4. What if it was 0 over here? What would it change to?
0.
It would just stay 0. What if I had a -5 over here? What would it change to? A +5. You just do the opposite sign. Now, let's put our rotation on the graph. So graph your new rotation. This is 90 degrees clockwise. So what quadrant will it end up with?
4.
Being in. It'll be in quadrant 4. And how do I write 4?
1V.
Is it 1V or V1?
1V.
Nice. 1V. Roman numerals. What quadrant is this up here?
2.
And this would be 3. All right, so now you know that your rotation is down here. We rotated it 90 degrees clockwise. And see what I'm saying? It's not like a reflection. We can't just go down, oh, I'm 1 from here, so I can go 1 from here. Well, it worked on the A, didn't it?
Yeah.
But how about the B?
No.
1, 2, 3, what am I, 4?
Yeah.
1, 2, 3, oh, that one would be down here. Where's the C? Right on there? So look at what the reflection would be. Here's if you were to reflect it. That blue one is your reflection. A little different than a rotation?
Yeah.
Much different, yes. Question?
Well, the first one looks like it should be, but the second one looks like it's a little flatter, more compact.
Optical illusion maybe? Since I drew this triangle on there, you mean?
No, after, but even before that, because it looked like it was
But, okay, maybe optical illusion. Let me see if I can take that off. Now just imagine, like we talked about, a spinner on a board game. If I were to grab this and then now spin this on a spinner, see how this didn't move? It stayed here, but this all spins this way. Notice this is on the x-axis, this one's over here on the y-axis now. We just have to keep rotating it. Yeah, it might look different, but it is the same because it's pointing a different direction. Let's do another one now. That one was 90 degrees clockwise. So here they want us to do one 90 degrees counterclockwise. So first thing you want to do is what?
Our thing, draw original.
Good. Draw the original. Connect the vertices. Alright. This is my original right here. Now I want 90 degrees counter clockwise. So, how many points? 3? I see 90 degrees. What's the first thing I need to do? Flip it.
Switch on.
What is the first thing I need to do when I see 90 degrees?
Switch on.
Switch them, flip them around. So, A, what's my new A going to be?
-1, 1.
I'm going to flip it around, get -1, 1. What's my new B?
-1 and 3.
-1 and 3.
-4.
-4 and 4. I just took these and flipped them around like that. Am I done though?
No.
No. Now we have to decide which ones do I multiply by -1? The X's or the Y's?
X.
Counterclockwise. Does that go left or does that go right?
Left.
Goes left. So we need to change all the X's. So this becomes a +1, +1, and a +4. There's the new coordinates for our rotation. So now let's plot our rotation. Why do you cross out the negatives again?
Times it by 1.
You multiply them by 1. That puts it in the other quadrant for you to go counterclockwise or clockwise 90 degrees. Okay, so this now turns into a +1. And they're no longer negative. And there we went. Here's my original. Here's my rotation. I went from here to here, which was counterclockwise, 90 degrees. I rotated it on the origin 90 degrees. Okay, now the last one that you have to learn for today on the worksheet. Now we've learned 90 degrees clockwise, 90 degrees counterclockwise. So now we have 180. Does it matter if it's 180 clockwise or counterclockwise? No. It's just 180 because you're going to be, when you do something and you rotate it 180 degrees, you're going to be on the opposite quadrant. Kind of like a vertical angle, the one that matches it. Here to here or here to here. So this is even easier than the 90 degrees because you don't have to do any flipping. You see 180, you just take your originals. Let's go right over here and practice. Okay, first of all, put your original on there. What quadrant is your original in?
3.
It's in quadrant 3. Now since it's 180, I know that when I'm done, my rotation better end up in what quadrant?
1.
Better end up in quadrant 1, the opposite. So now we got our original on there. Everybody's matched mine? Everybody got their original down there in quadrant 3?
Yeah.
Great. Now, this is what's the beauty about 180s. We don't do any flipping. So you take your originals. -4, I just rewrite them over here. No flipping, just rewrite them. -3, -1, -1, -2. Okay, there's my originals. Everybody got that part done? Yes, they're zipping through this. Now, I didn't have to flip them. All I have to do is multiply each and every one of them times a -1. So I have to change the signs of each and every one of these x and y coordinates. So this becomes a +4, positive. These all end up becoming positive. What if one of them would have been a positive?
Negative.
And then you'd make it a negative. Unless it's 0, it just stays 0. Now plot your new 180 rotation. Should match mine. It's up here in quadrant 1. Anyone need help? Questions? Questions are good? None? We got it? So it's the first thing you do when you see 90 degrees. You switch them, flip them, and then decide which ones to change. Multiply by a -1. 180, do you flip them?
No.
No, only change all the signs. All right, now this one. Before we did the, like it was a game spinner. Now this is just in place. I'm not spinning this about an axis now, I'm spinning this like it's just right on top of each other. If I were to spin this, does this figure have rotational symmetry?
Yes. Yeah.
Yes.
No.
Yes. Yes.
No.
The only way I could turn this for it to fit exactly on itself to match up would be what?
360 degrees.
Yeah, I'd have to do a 360. I'd have to turn it all the way around in order to get it to match up again. So this figure does not, nope. Fine pans will go. No rotational symmetry for you. How about B?
Yes.
It does.
Wow, yes it does. So let's go with the yes. But now we have to tell. If it does, tell the angle and the direction.
90 degrees.
So if we say this is our top, we could go here, right?
Yeah.
And that would be 90 degrees what?
Clockwise. Clockwise.
That would be 90 degrees.
Clockwise.
Both ways.
That would be clockwise. And we could also go 90 degrees counterclockwise, can't we?
Yes.
So in that case, I'm going to say yes, 90 degrees
Both ways.
both ways. And what else?
180.
I can go from here, I can turn it halfway and go 180, can't I?
Yeah.
Do I have to go 180 both ways?
No.
No, because when it's 180, you just pretty much know it either way. And 180 degrees. If you want to write both ways, you can. You don't have to. But on the 90 degree, you have to specify. Now, why can't I say 90, 180? What's 180 and 90?
360.
What's 180 and 90?
270.
Why can't I say 270 degrees clockwise?
Because that's the same as going counterclockwise 90 degrees.
That's the same as going counterclockwise. And in your definition, what does it say? If a rotation of 180 degrees or less, clockwise or counterclockwise. So we always use 180 degrees or less. All right, now the last figure. Oops, come back. There we go. Wow, look at that one. That one's going to get us thinking.
Yeah.
Obviously it is.
Yes.
Yes, majorly yes.
45 degrees both ways.
Ooh, I heard that one.
What?
I'm not going to say it. They didn't hear you. See if they can get it.
45.
Oh, they did hear. Okay, so say this is the top. We go to here. It's what?
45.
45. So 45 degrees both ways.
Then 90 degrees both ways?
You agree?
180.
Yeah.
And then we're going to have the 90 degrees both ways. Anything else?
180.
180. 180 degrees. Is that it? Are we done?
No, then 135.
Oh man, you guys are on the ball. Because these, what are these two? Because here's 90. And you said it's 45, so it's 90 and another 45 added together.
35.
We get 135 degrees. Is that one both ways?
Yes.
It's 135 both ways.
That's not numbers and letters.
That one was a good one. Questions on any of those? Yep.
For like tests and stuff, do you have to write every single degree rotation?
Yes. Yep.
How come C has three kinds and B only has two?
Just the figure is different because this one, if I did 45 degrees, would it match up on anything?
No.
No. All right, good questions. Today's homework. Worksheet that matches it. 13.6 due Tuesday.